first question asks us, what conditions do you believe would make it appropriate to assume independence in this situation? Well, there are a lot of different things, but primarily the one that we could probably think of is that these two people don't have contact with each other. So we'll just list that one. You could probably think of some more creative ones. We'll just say people do not have direct contact. So in other words, we're saying that if a person does have the flu and another person does encounter that person, he's probably a lot more likely than just 10% to get the swine flu. So B, by using the tabular approach and assuming independence, find the probability that both people have the H1N1 virus. So we have two people. We have person 1 and person 2. And person 1, well, there are 10 possibilities if we think about it in terms of percents. And out of those 10 possibilities, 1 means he does get infected. So we'll say infected, and then the other 9 times out of 10, he is not infected. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing for person 2, because we're assuming that person 2 is not affected by person 1, since we're assuming they don't come in contact, or that at least it doesn't affect the probabilities. So 5, 6, 7, 8, 9. And so now we can certainly answer questions about these. I'll just kind of make a quick distinction here. So we kind of, if we break this up, we'll see that we sort of get the 4 regions again. And these are where both people are infected. First person's infected, but the other 9 instances where person 2 isn't infected. And so we have these different regions here. First thing I'd like to do is just to go ahead and calculate the size of these. If I were to actually draw out all the rows and columns, we'd note that this is a 1 by 9. And so that means there are 9 cells in here, or 9 possibilities where person 1 is infected but person 2 is not. There's a 1 by 1, which is equal to 1 case where both of those people are infected. Now this is out of 100 because we have a 10 by 10 table. Now this guy is similar here. This is going to be a 9 by 1. And so that's going to equal 9 different outcomes where person 1 is not infected and person 2 does become infected. And then a where both people don't become infected is a, well, this is 9 no's, 9 no's. So 9 by 9 equals 81. Now you should note that these should all add up to 100. So 81 plus 9 plus 9, that's 99, plus 1 is 100. So perfect. Math is fine. So we wanted to answer the probability that both people have the H1N1 virus. Well, probability that they're both infected, so I'll just say I and I, person 1 and person 2, is 1 situation out of a total of 100 situations, which translates to 1%. Okay, part C asks us, by using the AND rule, verify that you get the same answer that you found in part B. So under independence, remember that the probability of I and I is just equal to the probability that the first person's infected. I guess we should call this Fi and Si. The probability that the first person's infected times the probability that the second person is infected. Again, because this is under independence, so the probabilities are not affected by one another. Probability that the first person's infected is, well, 1 out of 10 cases, times the probability that the second person is infected, which he or she has the same chances, and so again we get 1 times 1 is 1. 10 times 10 is 100, and so again we get 1%. Part D asks us to find the probability that neither of these two individuals has the H1N1 virus, and we can see right away that that's going to be 81 out of 100. So I'm going to pull my D up here and I'll say that probability that they're both not infected is there are 81 out of 100 situations where that would happen. So there's an 81% chance, which is pretty good, that neither of these two people get infected. Part E, find the probability that at least one of them has the H1N1 virus. Now remember, the probability of at least one infected is going to be, well, all 3 of these situations where one or more of them is infected. So that's going to be the probability of infected and not infected. So person 1 is infected, person 2 is not, plus the probability of the first person not infected and the second person infected, plus the probability of both the individuals being infected. So we'll say I and I, and I'll make a little correction here. Oops. just going to fix that. It's kind of like an R. So probability of I and I. Now, so this is going to be, well, there are still everything's out of 100, so the denominators are all 100. So it's all going to be over 100. The infected and not infected, that's 9. Not infected and infected, that's 9. And then infected and infected, that's 1. So that's 9 plus 9 is 18. That's 19 out of 100 possibilities, which is 19% chance. Part F says exposure to flu germs for even a short period of time can significantly increase one's chance of catching the flu. Suppose that if one is exposed to an individual with a flu virus, their chance of becoming infected is 15 percentage points higher than normal. Find the probability that both individuals have the flu virus. Come over here to the next page. So here we are actually taking into account the fact that there is going to be some conditional probability here. So the probability that person 1, so I'll just say Fi just to be specific because now it does matter. So first person infected and second person infected. Well, that's still the AND rule, but it's the AND rule for dependent events because the second person being infected, so times the probability that the second person is infected, provided that the first person was infected. So remember that they're coming in contact, so person 2's probability is a little bit higher now that he's or she has been in contact with person 1. So we already know that this is 10%. So I could use 10 out of 100, or I could use 1 out of 10, but I'll just use 0.10. I'll use the decimal version. And the probability that second person is infected, given the first person infected, remember, well, that's 15 percentage points higher, so this is going to be 0.10 plus 0.15, which is actually 25% chance. So we're going to come over to our calculator, and we'll multiply these 0.1 times 0.25, and that gives us 0.025, which is 2.5%. There's a 2.5% chance that both of these people become infected.